Okay, hi everyone, welcome to ASR Academy. So in this video I will be explaining the ray diagrams of the convex and concave lens. Okay, so let me tell you how there are around 6 ray diagrams related to convex and concave, and we'll see them. Okay, so what is the position of object and where we'll be going to get the image. So these two are the symbols. This symbol is representing the biconvex lens. This symbol will represent the biconcave lens. And at the center, at the midpoint of this lens, will have an optic center, and this lens will have a principal axis. Let me draw the principal axis. So it has two centers, C1, C2, and also it has two focal point, F1, F2. Let me draw the same thing for the biconvex lens, C1, C2, F1 and F2. See, whenever you are drawing the ray diagrams, so you should remember that the distance between the pole and focus and the distance between the focal and center should be same. Okay, ఇది రెండు distance same ఉండాలి, ఇక్కడ కూడా రెండు distance same ఉండాలి. So in your if I talk about the ray diagrams of concave and convex lens. So in concave, I told you will be having 6 ray diagrams, where in the convex we will have only 2 ray diagrams. So why here we have 6, why the 2 in convex? Okay, I will explain. See, in the case of biconvex, we can place the object at infinite. So we can place an object at infinite. We can place an object beyond the C2. We can place the object at C2. Next, we can place an object between C2 and F2. Next, we have a position. We can place an object at F2. And also we can place an object between optic center and focus. So totally, if you count, we'll have 1, 2, 3, 4, 5, 6. 6 places. There are total 6 places where we can place an object. But in the convex lens, also we can place the object at 6 different places, as we have placed in the convex lens. But what we observe, so when the object is placed at infinite distance, the image will seems to be formed at the focus. But when you place an object beyond the C2, at C2, between C2 and F2, or F2 or between optic center and focus, we'll find that always image will form in between focus and optic center. So that is the reason why we'll have only 2 ray diagrams in biconvex lens. Okay, so let me draw the ray diagrams. So yes, in the previous video I have explained you the situations. You can say the rules of the ray diagrams. How the ray get bent when a ray is passing from the convex lens. How the rays get bent. So I will show you. So let me take the first ray diagram. So in the first ray diagram, we will be taking the object at infinite. Okay, so first let me draw so I am just now explaining the ray diagrams of which lens? Convex lens. So this is nothing but this is a convex lens. So now I am explaining the ray diagrams of which lens? Convex. Biconvex lens. So this is an optic center. Let me take the equal distance, right? We have to take the equal distance. So this is here we'll have take focal point F1. At the same distance I will be taking the center of curvature, C1. So right side also at the same distance I have to put the F2 and C2. You can take the help of the scale. You just make a 4 centimeter line and make a 1 centimeter or 2 centimeter distance. You just plot this 4 points. Okay, the midpoint will be the optic center. So as I told you the first case, so this is my first case, object. So position of the object will be at infinite. So when the object at infinite, so we'll be writing the image. What is the position of the image? Next we'll write what is the characteristics of the images. Okay, so we'll write the characteristics of the images. So object is placed at infinite. So whenever the object is placed at infinite, so we have to consider the rays are parallel to principal axis. So in this case also we'll consider that the rays are parallel to principal axis. Okay, so let me take 2 rays which are, this is my principal axis. So let me take the ray which is parallel to principal axis. So this is a first ray, this is a second incident ray, these two rays are parallel to principal axis, they are incident ray. So when these two rays which pass from the convex lens, according to the situation 3, they will be passing from the focus. Okay, so these rays will be passing from the focus. So whenever the object at infinite, the image will form at the focal point. Okay, what is the characteristics? We will be going to form a point size image. Okay, so in the first ray diagram, the object will be placed at infinite. We have to consider rays are parallel to principal axis. So we'll see that the rays will converge at focal point and we'll get a point sized image. Okay, and this can be seen in this picture as I show you. Okay, if it's asking to draw a ray diagram when the object at infinite, the image will be formed at focal point. This is the point size. We cannot say the more characteristics about that. So next ray diagram is, in the next ray diagram we have to place the object beyond the C2. Okay, so let me place an object beyond the C2. So I am not going to rub this all, because again we will be using the same ray diagrams. I will be taking the same ray diagrams to explain the next one. So I am just placing the object at beyond the C2. So object is at beyond the C2. So if the object is placed beside the center of curvature, beyond the C2, it doesn't mean you can also place the object at here, but the image will form on the right side. So let me take an image object which is placed beyond the C2. This is my object. You have to draw a 1 or 2 centimeter arrow mark. This can be represented as an object. So object position is beyond the C2. So I am using the third rule number, situation 3, when the rays is parallel to principal axis. So whenever rays is parallel to principal axis, it passes from the focus. So let me extend this line. As we know, this line will pass from the focus. So second ray, I am taking a ray which is passing from optic center. So let me take a ray, incident ray, which is passing from optic center. We know that whenever a ray is passing from optic center, it doesn't deviate, it will travel in straight line. Okay, so whenever you take a ray which is passing from the optic center, it is not deviated, it will travel in straight line. And we found that both the refracted rays are intersect at this point. Okay, this is the intersectant points of both the lines. So this is our image. So we got the image in between. Image is between F1 and C1. So we got the image is formed between F1 and C1, right? And we have to write the characteristics. See, this is invert. So this is invert. So you can say we have to put a screen here. Okay, we need to put a paper or something as a screen. So the image is formed is real invert. Next we have to talk about the size. So size will be small. Okay, the object is bigger in size, image is small in size. So whenever image is small, you have to write it is diminished. Okay, the object is formed between F1 and C1. The characteristics of the images is real, invert and diminished. So next let me take the object. Now this is the second one. Okay, so let me take the object at C2. So next area diagram where the object will be placed at C2. Okay, so object will be placed at C2. So let me place an object. Okay, let me draw a straight line first. So when the object is placed at C2, so I have to draw a line. This will represent the object. So let me take an situation 3. A ray is parallel to principal axis. We know that whenever a ray is parallel to principal axis, it will pass from focal point, right? And next let me take a ray which is passing from optic. Okay, which is passing from optic center. And we'll find that with this ray, whenever is passing from optic center, it is moving in straight line without undeviation, and we'll find that both the rays will be intersect a point at C1. So whenever the object at center of curvature C2, we got the image at C1. We have taken a ray parallel to principal axis which passed from focus. Second ray which is passing from the optic center, it is not deviated. We got the object at C1 when the object is placed at C2. See, the image will be real, characteristics are real, it will be invert, real. Whenever the image is real, it will be invert. And C1, the image is same size, so you have to write the characteristics as image is formed of same size. Okay, so this is the third case where the object is placed at C2. So now we have a position, we have to place the object. Okay, now we will be placing the object in between C2 and F2. So let me draw the convex lens, and this is my principal axis. Let me plot arrows and let me put the points F1, C1, F2, C2. So now I am choosing the object will be in between C2 and F2. So when the object is between F2 and C2, so let me take an object, and we'll be taking the situation theory, rays passing parallel to principal axis which will be passing from focus. Second ray will consider a ray which is passing from optic center. Okay, so whenever a ray is passing from optic center, so we'll find that both are intersecting beyond the C1, right? Here you can see. So first ray we have taken a ray parallel to principal axis passing from focus. Second ray I have considered a ray is passing from optic center, it is undeviated. Both will intersect beyond the C1. So whenever the object is placed in between C2 and F2, we find that object will get the object beyond the C1, sorry, not C2. It is beyond the center of curve. Characteristics you can see. It is real, invert, and it is object is small and image is bigger. So we have to write magnified or bigger in size. This is the characteristics. Okay, whenever the object in between C2 and F2, image is beyond the C1 and the image is real, invert and magnified. Now let me take the object at F2. So when you place the object F2, so okay, let me just rub this line. Okay, so now it's clear. Now we can take the object at F2. So whenever you just take the object at focal point F2, so we have to take a ray parallel to principal axis which is passing from the focal 1. So now take me a ray which is passing from optic center. So let me consider a ray which is passing from optic center. So this is a ray which is parallel to principal axis, will pass from focus. This is a ray which is passing from optic center, it is not deviated. We can see that. So if you extend them, as they will be intersect at infinite distance. So when they are, so image will be formed at infinite. So we don't know where the image will form. So that is why. So we cannot say the characteristics. So whenever we place an object as focal point, okay, the image will be appears at infinite. So we can see in the figure. So whenever the image is formed at infinite, we cannot discuss the nature, okay, and size. So nature and size is not discussed. We cannot tell you the characteristics. Next, the last case is sixth case, when the object will be placed in between optic center and center of curvature, not optic center and focal point. So this is somewhat important, and most of the time we will be finding an image which is virtual. In this case, we'll find that images, which is whatever the image is found will be the virtual. So now we have to place the object. So what is the position of object? Position of object is between F2 and P. So we have to place an object in between optic center and focus point. So let me place an object which is in between optic center and focal point. So we will take the rule 3, ray parallel to principal axis. Whenever ray is parallel to principal axis, it will pass from focus. Okay, and next let me take a ray which is passing from optic center, so which is also not deviated. So we got these two rays. As you extend, they won't get intersect. So now we need to extend them behind the lens. So we find that, so they are, when you extend the line behind the lens, they get intersect at a point. Okay, so we can find that an image is found behind the object. So in this case, when the object is placed in between focus point and optic center, the image which we'll find, it is found behind, right, behind the object. The image is found behind the object, right? So the characteristics of the image will be, we got the image above the principal axis, so it will be virtual. Whenever it is virtual, it is erect. You can say that object is small, image is bigger. We have to write it is magnified. So in this ray diagram, we notice that the image is virtual, erect, and formed at the same side of the lens where the object is placed. And the size of the image is bigger than the size of the object. So it can be also known as magnified image. So it means that whenever the object is placed in between focal and optic center, the image will work as a mirror. It will be working like a mirror. Okay, ante manaku lens meedane image kanipistundi. We are able to see the image on the lens. So image is found beyond the lens, you can say, beyond the object or beyond the lens. Okay, these are the 6 ray diagrams of the biconvex lens. In biconvex lens, we have find that image are found real, erect. Okay, in 5 cases. In the last case, we find that the image is formed is virtual. Okay, let me take the ray diagrams of concave lens. So first case of the concave is when the ray is parallel to principal axis. So this is what the symbol of concave, biconcave. Okay, now I explain the ray diagrams of biconcave lens. So now let me take this point as a focal, f2, c2, f1, c1. So let me take some rays which are parallel to principal axis. I am taking the 2 rays which are parallel to principal axis, and we know that these 2 rays, whenever they are parallel, they seems to be diverge from the focus, right? So yesterday in the previous class, I have explained you the thing. Whenever a ray is parallel to principal axis in the biconvex lens, they get diverged and seems to be coming from the focus. So it means that when the object at infinite, we will get the image. We are getting the image at focal point. Okay, we are getting the point size image. The image whatever we'll get here, so it will be of virtual, right? So here in this case, we will be going to get a virtual image. Okay, point size at the focus point. And the second one, see, now we can take an object. Okay, as I told you, in this biconcave lens, we'll be having only the 2 ray diagrams. So one is ray parallel to object at infinite, and second one is object in front of the lens. So now let me place an object. Okay, let me correct this diagram so that it will be visible. Okay, so now let me place an object. Okay, now we'll place an object in between C2 and F2. So if you place an object in between C2 and F2, the first one is we will be taking the ray parallel to principal axis. Second ray will be taking which will pass from the optic center. We know that whenever a ray is passing from optic center is not deviated in the case of concave and convex both. So but in this biconcave lens, the rays parallel to principal axis seems to be diverged from the focus. See, if you see these 2 rays, they are getting diverged. They won't meet. But when you extend this one, so the image will form between optic center and focus. When the object, you can say when the object is in front of lens, the image will be formed always the image will be formed between optic center and focal point. So it will be virtual. The characteristic will be virtual, erect, and it will be diminished. You can see here the size of the object is greater than the image. Image chinnaga undi, object peddaga undi. Not only this, if you take the image, if you take the object in between focus and optic center, we'll see that one. Okay, I'm just explaining the one more ray diagram. Let me place an object in some other position so you can have a clarity why we are getting only 2 ray diagrams. See, whenever you place any object at any distance in front of the concave lens, we will be going to get virtual image, virtual, erect and diminished. Okay, now I will place an object in between pole and focal point. This is my object. So let me take an ray parallel to principal axis and a ray which is passing from optic center, right? So we know that whenever a ray is parallel to principal axis, it seems to be diverged from focus. So this will seems to be diverged from focus, and a ray which is passing from optic center is not deviated in biconcave lens. So we have seen that both the rays, they are not intersecting here at this point. So we got that whenever you place an object in front of the biconcave lens, we'll get the image in between focal point and optic center. The image will be always virtual, erect and diminished. Okay, so I have explained you the 6 cases of biconvex lens and 2 cases of biconcave lens. In biconcave lens, the object will be placed at infinite. The second case is the object will be in front of the lens. Okay, so you just practice the thing which I have explained. Okay, they will be asking in the exam. Okay, so I am just going to end this video. Have a nice day.